Hi guys. Back for chapter 15, section 1. We're going to talk about waves. Great job last chapter. I feel like you really hung in there. We are gearing up towards making those musical instruments that you guys probably saw in my classroom before we left. So for this information, because it's working towards something that I think you guys are going to find to be really fun. Okay. All right. So let's start off with section 1. It does talk about your waves. I've got my little pieces of paper here, hopefully to help you some. So we're going to talk about more than just one type of wave. We're going to talk about the different types. We're going to talk about what those different types would look like if you could see them. For our, we draw a wave with a up and down motion, okay? And those are actually going to have parts, okay? But as we are talking about waves, the main thing about waves is to know that it transfers energy from one place to another, okay? So it's going to take that energy and it's going to move it from here to there, all right? Your book will show you a picture of candlelight, and it's showing you that the candlelight is your energy source. Okay, so that flame is going through that chemical change and it's burning, and you see the light, and that light doesn't just stay right there, does it? That light moves outward. Okay, so waves are going to move outward from the direction of their energy source. It be up, it could be down, left, right, diagonal, whatever. As long as it's going outward in all directions, that is the direction of your wave travel. Okay. Let's move on. You got one specific type of wave, and those are called mechanical waves. Mechanical waves are broken down into two main parts, and then they're going to have 3 types of those. Okay, so when we talk about mechanical waves, we are either going to say that they are transverse or they are longitudinal. Okay, and all that means is how that wave moves is going to give it a different name. All right, so the thing about mechanical waves that you need to remember, these waves are going to travel through matter, but they do not travel through space. Okay, that vacuum that space is, nothing can get through except for light. Mechanical waves cannot travel through those as well. Okay, so let's break down transverse and longitudinal. Okay, so transverse gets its name because the wave is going to travel perpendicular through the disturbance. Okay, so if my disturbance is right here, is this dotted line, my wave is going to go up and down around that. All right, so remember, just recapping your math classes, perpendicular means at a right angle. Okay, so they're intersecting there. All right, so transverse waves, you have 2 parts to a transverse wave. Okay, so if it's above this disturbance, we'll call that rest sometimes. It's above it, it's the crest. The crest is the highest point that it reaches. Okay, and on the flip side of that, you have the trough. The trough is the lowest. So just like you would have animals that might eat out of a trough, those troughs are on the ground, they're low. Okay, so we also have longitudinal waves. Longitudinal waves, still mechanical waves, but they have a little bit different parts. Okay, longitudinal waves are going to have compressions and rarefactions. All right, they are different from your transverse waves. Your compressions are going to be the points of the wave where they are tightly packed together. Okay, so this part where they're real close, those are compressions. Just like if you compress a soda can, you're squishing it together. Okay, the rarefactions are where they are spread out. So when they're at their farthest point, all right? Okay. Rarefactions are when they are far away. Okay.
What kind of water?
Yes. Yes. Okay. So that's your two specific types of mechanical waves. We can also break down mechanical waves into three main categories. Okay, so some examples of a mechanical wave, you're going to see sound waves, water waves, seismic waves. Okay, your sound waves, hopefully you can see from the drawing, they've got compressions and rarefactions. So sound waves are going to be longitudinal mechanical waves. All right. Then you have water waves. And again, that's super easy. It's waves in the water. All right. So how do we get water waves? Wind blowing might push it around, and that's what's going to happen. The wind is going to push that wave. So whichever direction the wave is going, that is how the wind is pushing it. Okay. Water waves are unique in that they can be transverse or longitudinal. They don't have to be just one. Okay. Then you have seismic waves. So you have a fault line, which would be a crack, and then what happens are these waves go out from that fault. And just like with our picture earlier about the candle flame, these waves are moving outward in all directions. Okay, so we start at the fault deep inside the earth and we move out. And again, seismic waves can also be transverse or longitudinal. Okay.
Hey!
So along, your other main type of wave is going to be the electromagnetic wave. Okay. Electromagnetic waves, if you can see right there, go through matter and space. Okay, so not just matter. These are your special ones. These are the ones that can go through outer space. Okay. So I put some examples for you. We've got radio waves, we've got microwaves, we've got infrared, and we've got UV. Okay. So radio wave, think about like your satellite dishes. They collect the waves coming in through space. Okay. Microwaves you use every day because it's from your cell phone. Okay. Cell phones use microwaves to move sound from one location to another location. Okay. Infrared, you may, if you're a movie buff, you'll see them in like heat-seeking missiles or night vision goggles or things like that, where it's taking the heat that an object gives off and using that to track someone. Okay, so infrared is being able to see the heat waves. Some animals have it. Usually your predators, like a snake, would have this, and they could see the heat energy of maybe a mouse, and they would know where that mouse is, and they could strike, and they could use that as a adaptation to survive in the wild. Okay, so lots of infrared happening around you, whether you realize it or not. Okay. The last one you have is UV. That is ultraviolet radiation. This is going to come from the sun. You guys know what this is. It's very similar to that radiant energy, but this is the harmful one. Okay. Those are your electromagnetic radiation, your waves. Okay. That's it for section 1 in a nutshell. We will get back together on section 2. We're still talking about waves, and we will move forward from there. If you have questions, please ask them. Miss you guys still. All right. Look forward to seeing you sometime, okay? Bye.
Hey, can I finish our board?